Well, so this is a question. Question is from mechanics. The question is AB is a light rigid rod, you can see, which is rotating about a vertical axis passing through A. A spring of force constant K and natural length L is attached at A, and its other end is attached to a small bead of mass M. The bead can slide without friction on the rod. At the initial moment, the bead is at rest with respect to the rod and the spring is unstretched. Select the correct options. The maximum velocity attained by the bead with respect to the rod is this. So we have to find the maximum velocity of the bead and we have to find the maximum extension in the spring. And also we have to see the maximum value of contact force between the bead and the rod is greater than mg. These are the some options given. We have to do. Well, students, so let me do this question. Well, so let me check once it is. I hope it is. All right. Let me do this question. Well, so let me also start recording now. Well, so we have to at the initial moment the there is no elongation in the spring, and then the rod is start rotating about the vertical axis with with a constant angular speed omega. Well, so how we will do this question? We know that as it starts, the rod starts rotating about this vertical axis, and the one end of the rod is fixed with the spring, and the spring is another end of the spring is connected to the bead, which is connected to the rod. Means the bead can move smoothly along the rod, right? It can slide smoothly along the rod since there is no friction. So this is the situation. So once we start, we give the angular speed omega to the rod about this vertical axis. We can understand that the bead will move away from the axis and the spring will elongate. Why the bead will move away from the axis? This we can understand in a better way. If we consider, an observer which sitting on this rod, right? An observer sitting on the rod at near bead or at bead, the observer is sitting here. So this observer is a non-inertial observer since it is rotating with angular speed omega. So there is an acceleration towards the center, right? Towards this axis. So because of this acceleration of the observer, this is a non-inertial observer, and then for this non-inertial observer, when he observes the motion of the bead, the forces acting on the bead, apart from the real forces, that is, real forces will be kx if the spring once the spring is elongated, its weight mg and normal reaction. He must consider a pseudo force in case of rotation. We can call it the centrifugal force, and that force will be mass of the bead multiplied with the acceleration of the observer. Since the acceleration of the observer is this side, so that pseudo force is opposite to that. We know that it is ma, but direction of this pseudo force is opposite to the direction of acceleration of the observer. So let me draw the FBD of the bead with respect to the observer frame, that is non-inertial frame of reference, and that is the rod frame, and that rod near bead. Then, or at bid even we can say. So, what would be the forces acting on the bid? One is its weight, mg, other is the normal reaction, and then suppose there is some elongation x at that moment, then it will be kx. And since we have to consider the non-inertial observer, we have to consider the centrifugal or pseudo force. That will be M into A, or A will be what? Omega square. At that moment, suppose the position is like this. This is the axis, and this is the spring. And suppose at this moment the length will be L naught, the natural length of the spring, plus x, because x is the elongation. So acceleration will be what? This is the about this point it is rotating, right? The observer is rotating about this point. So their acceleration will be omega square L plus x. I hope you got this thing. So this is the acceleration of the observer, right? This is the acceleration of the observer from here, right? So this is their radius, which is equal to L naught, natural length of the spring, plus x, which is the extension or elongation at this moment, at some moment. So we can say the force acting on the bead will be in along the rod. If I say is the kx and m omega square L plus m. And students, we should know few things. And when the block or the bead or the will have the maximum velocity, you must know this thing. And that is, if you have solved the question, the simple questions, which is quite similar to this one, but if you have solved this question, which is very common, like there is a spring and there is a block, and you are holding this block, and this is the natural length, and then you release it, then at what moment, at what instant, or at what position its velocity will be maximum. So the velocity will be maximum, when the net force acting on it is zero, that is the equilibrium, because this is mg and this is kx. Because if I say in brief, I will tell you the force acting mg will be downward as we remove the hand, and the kx will be start growing from zero, because at initial moment there is no elongation, but mg is a constant force. So net force is downward, and then acceleration is downward. So the particle will continuously attain the velocity which is increasing. And when at this position, suppose when kx is equal to mg, x is elongated this value such that kx is equal to mg. So net force will be zero. That is the condition of equilibrium. And at the moment when net force is zero, by that time the body will attain the velocity that is maximum. Because after this, after equilibrium, kx will be more than mg. So this force will be upward and velocity is downward. The motion is retarding. So it will be slowly come to rest for a moment and again go back. So from equilibrium position to downward motion, what will happen? Its velocity decreases. So first velocity increases. So at equilibrium, the velocity is maximum. So that I hope you know this basic thing. So similarly, what will happen here also, because of this force, the body will start moving away from the axis along the rod, and as it starts moving, the kx will also come into the picture. The net force will be rightward or along the rod, outward, I should say. So that will produce acceleration, and because of that acceleration, velocity will be increasing. And again, the same situation, at equilibrium, its velocity will be maximum, right? And after that, what will happen? This force will be more than this one. All right, so that is very clear to us now. So let us first find the equilibrium position where the velocity will be maximum. So for equilibrium, we know the force, net force on the body should be equal to zero. We are interested along the rod, vertical anyhow, it is zero net force. So here, even in there may be some other forces acting here apart from N, which we will discuss later, right? So which we will discuss later. But anyhow, this is how in a simple way we are saying. So net force along the rod, if I say along rod, then it will be what? M omega square L plus x minus kx is equal to 0, and I can write m omega square minus k into x, m omega square is equal to minus m omega square L. Or I can say kx is equal to m omega square L upon k minus m omega. I know this is what I got this is the position of the bead, along the rod. This is the position of the bead somewhere here, along the rod. I can say this is the rod. So this is the position of the bead, where the velocity will be maximum. Now I will say this is the equilibrium position. Let me write the xe. This value is what I am saying x. I will call this x to be x. Now, so it is clear to us that at this position, is the rod, and at this position, that is L naught plus x e, the velocity will be maximum. But how we will find, and here at this position the force is 0, but how we will find this maximum velocity? See, we can find the maximum velocity. What we should apply, since we have to find velocity, should we apply the conservation of energy? No. There is a force acting on the bead. That is which force? That is the pseudo force with respect to non-inertial frame of reference for that observer, and because of that is considered to be an external force, so we cannot conserve the energy. So definitely we should go for work energy theorem, and that is a better choice in most of the questions where there is some external force or friction. So definitely we have to go for work energy theorem. Only when there is no external force, there is no friction, no air resistance, no resistive force, no loss of energy, then we can apply conservation of energy. So let me go here with work energy theorem. And that is also with non-inertial frame of reference. For that observer we are applying this. So what we can write here, the work done by spring force, which you can understand, the work done by spring force plus work done by m omega square L plus x at some moment in between. So let me write even this to be x at some moment of time, x. So work done by spring force plus work done by this centrifugal force or pseudo force. Let me write pseudo force. These two forces, these are the only two forces because there is no other forces for which there will be work done. Normal force mg or whatever the contact force that is perpendicular to the motion. So these are the two forces contribute the change in kinetic energy. So I will write K final minus K initial. And we are talking the maximum kinetic energy for maximum kinetic energy. And for that we will write when it passes through the equilibrium position. And so I can write simply it will write 1/2 mv square minus Q. So that's fine. Now what we can write for work done by spring force at some moment of time from the natural length when the elongation is x, right? The work done by spring force is what? That is equal to let me write, minus half kx square. And student, sometimes even in, most of you, if I ask the student, "Okay, what is the work done by spring force?" They say half kx square. Should not commit mistake. In MCQ type exam, your small mistake will give you the wrong answer or no answer. So be careful. Mistake is not allowed in MCQ type examinations. You will not get marks on steps. All right. So work done by spring force is minus half kx square. That is very obvious. Kx is left side and dx is right side, and we integrate, we get minus half kx square. You should know all the basic things. Now work done by pseudo force. Now tell me, this pseudo force is depends on x, so it is not constant. So we have to integrate it. So let me integrate this work done by pseudo force, that is integral m omega square L plus x dx, and that from x is equal to 0 to x is equal to x equilibrium, that is the position when it passes through equilibrium velocity is maximum, and that is equal to what, half. So let me do the calculation, what we should write. So let me do this part first. Okay, so let me do this part first. So this integration of, let me write m omega square outside, it will be L plus x, L plus x dx, and that could be 0 to xc. So only this part I am doing first, and this will be what, m omega square L x e minus x plus x e square. I think x e square by 2. I think for dx it will be x, L is a constant, for x it will be x square by 2. So put the limit, it will be x e square by 2. So what we have now, we got, then we can write minus 1 by 2 k x square plus m omega square L x e plus m omega square x e square by 2 is equal to half mv. Well, so student, we got some value. In equilibrium, you got m omega square L. See here carefully, m omega square L, because calculation we have to do. So m omega square L, I can write x e into k minus m omega square. So let me change this. So I want to write like this, minus half k x square plus, or you can do the calculation as according to your style. M omega square L, I am writing x e into k minus, I am writing this. Let me take this off me, and let me tell you a little this here. So I am writing this here. So I can say m omega square L is equal to k minus m omega square into xc. This is xe, right? Xe into xe is xc square plus m omega square xc square by 2 is half mb square. So some calculation is there. So I can write minus half k x. X is again what? At equilibrium it will be what? Xe square, right? So what will be the work done by spring force till when it reaches the equilibrium is half minus half kx square, and then I can write here kxe square. Then I can write here minus m omega square xe square, and then I am writing here m omega square xe square by 2, and this is equal to half mb square. So this and this will be kxe square by 2, and this together we will have minus m omega square xe square by 2 is equal to what, 1 by 2 mb square. So this 2 is out. So this will be k minus m omega square into xe square is equal to mb square. And let me write this k minus m omega square, and let me put the value of xe square in this. So this will be m omega square L upon k minus m omega square. Why have written like this? This will be m omega square. So this will be m omega square L upon k m omega square whole square is equal to mb square. So this will be one, this is out, so it will be m square omega compressed to 4 L square upon k minus m omega square is equal to mb square. One m is out, and then v will be m upon k minus m omega square, this come under root, and then omega power 2l. So this is what we got, the maximum velocity, right? Which option is correct? Let me check. Option is omega power 4l square. So this one A. So this is the option. Correct option is A. Maximum velocity is this. This omega power 4 and L square is they have put into within the square this under root bracket. So even we can write what V max is what m omega to the power 4 L square upon K minus square root में ही रखा है. So this is what is your answer. I hope you got this question. It is clear to you. मैं समझता हूँ कि आप समझ गए हैं पूरी बातों को. And then there are some other parts of this question, that is when there will be maximum elongation, what will be the value of maximum elongation? Again, I can say you just compare with the basic question from this question. If in this question the elongation in equilibrium is mg by k, and then maximum elongation is 2 mg by k. If it started from rest, then elongation is mg by k in equilibrium, and twice of that will be in for maximum elongation. And same thing, you can say the maximum elongation will be double of that, right? And then the option will be this C. The C is the correct option there. So, but anyway, if you want to solve it by the method, so definitely you can apply the work energy theorem once again. And this time it is simple because for maximum elongation, what will happen? The velocity of the bead with respect to the non-inertial observer, that is the rod observer, the observer sitting at the rod, for him the block will come to rest, right? The velocity is zero, and that is the situation for maximum elongation. यदि velocity होता तो क्या होता और भी elongate, velocity है किधर, राइट वर्ड की बात मैं कर रहा हूँ. तो इक्विलिब्रियम पे मैक्सिमम है, और जैसे ही इक्विलिब्रियम क्रॉस किया तो क्या हो जाएगा, सेंट्रीफ्यूगल फोर्स कम पड़ जाएगी और kx की वैल्यू ज्यादा होने लगेगी, राइट? And then it is a retardative motion will be there will be retardation. तो ये मोशन क्या हो जाएगा, रिटार्डेशन हो जाएगा, और इसकी जो स्पीड है वो कम होते होते एक्सट्रीम पोजीशन आ जाएगी जहां जीरो. तो यदि आप इसको वर्क एनर्जी से करेंगे तो कुछ भी नहीं करना है, बस यही इक्वेशन लगाना है. बस चेंज इन काइनेटिक एनर्जी जो है ये क्या हो जाएगा, के फाइनल विल बी जीरो एंड के इनिशियल आल्सो जीरो. So this will be 0. So when we put this to be 0, so what will be there? Then you come to this final equation which I got, that is from here from this equation, one moment, from this equation I can write this to be 0. Only thing, so we can write this to be 0. There is no change in kinetic energy, so this 2 will be not out at this moment. So what will happen then? Then k minus, we cannot put this value of xc, it will be x. So let me rewrite this value. So let me rewrite this value. Okay. Let me rewrite this value. Only thing, in place of xc, I will write what, x. I hope you understand the things. This is what work energy theorem. In place of xe, I will write what, x. So let me rewrite minus half kx square plus m omega square lx, no xe, lx plus m omega square x square by 2 is equal to change in kinetic energy, that is 0 minus 0. अब मैं यहां से x कॉमन ले लेता हूं तो क्या हो जाएगा, k x by 2, and this will be plus minus kx by 2 m omega square l, and then plus m omega square x by 2 is equal to 0, because x cannot be equal to 0. Then let me take x common, x by 2 common, then it will be m omega square minus k, and I put this other side is m omega square l. So x is equal to 2m omega square l upon k minus m omega square, and this k will be x maximum, because this is the x I got by considering the change in velocity is 0. So you got this thing. So you got the maximum elongation and you got the velocity, maximum velocity, and this idea is very clear to you. The velocity is maximum when the bead passes through equilibrium, and it is also clear to you that at extreme position the velocity is zero, and that is how we got the maximum elongation from work energy theory. Now, let me come to the next part also, the next option. Other option is also given one option that ये तो सही हो गया सी, ए सही हो गया तो बी रॉन्ग हो गया, और डी की बात करते हैं हम. डी में क्या है? द मैक्सिमम वैल्यू ऑफ कांटेक्ट फोर्स बिटवीन द बीड एंड द रॉड इज ग्रेटर देन एम. फर्स्ट ऑफ ऑल, should this question be there for JEE Advanced? But anyway, uh, let us do this part also. Let us do this part. Student, if you see from the ground frame, how is the motion of the bead? The bead is moving along the rod. So, if from the rod frame, the motion is, it is going from initial to equilibrium to extreme, and then again come back like that to and forth, to and fro motion, and then back and forth motion we can say, and then it is what like a simple harmonic motion. It is a simple harmonic motion from the rod frame. Even we can do the same problem, maximum velocity, with help of simple harmonic motion. So we will do that also. But anyway, let me discuss first the option D. कि क्या जो कांटेक्ट फोर्स होगा वो mg से ज्यादा होगा? देख के तो नहीं लगता है. लगता है कि mg एक फोर्स है नीचे, और रॉड जो रिएक्शन देगा वो mg के बराबर होगा, क्योंकि कोई फ्रिक्शन है नहीं, तो अलोंग द रोड कोई फोर्स लगने वाली नहीं है. बट एक्चुअली इसकी मोशन जो हो रही है, इसमें जो बीड है वो अलोंग द रॉड भी मूव कर रहा है और सर्कुलर पाथ में मूव कर रहा है. मीन्स इनफैक्ट ये प्योर सर्कुलर नहीं है, ये ऐसा सर्कल है जिसकी रेडियस चेंज हो रही है, स्पाइरल की तरह है, राइट. एंड व्हेन दैट इज नॉट देयर, इनफैक्ट आई डोंट थिंक इट इज देयर इन JEE Advanced, बट सपोज लेट अस डू, इफ यदि रेडियस चेंज होती हो और एंगल तो चेंज होगा ही, सर्कुलर मोशन है तो, so what will be the acceleration of the particle? So let us see, let us do this thing. Okay, let me say something about circular motion to you. What we know that if a particle is in circular motion and moving with some velocity v and some moment of time, suppose it turned an angle theta, so we write its acceleration. If I consider this to be a unit vector ER along R, or towards center I am considering, and along tangent is ET, then we write the acceleration is minus omega square R ER plus R alpha. That that ये तो आप जानते हैं, sorry, R alpha ET. So this we know this is the centripetal acceleration, or this is the tangential, or I can say this is the radial acceleration and this is the tangential. But what happens if this R vector is changing, right? R vector is varying for circular motion, but mod R is constant, right? But what happen, what will happen if mod R will also change? That is what is happening here with respect to ground frame. When this bead is moving like this also and rotating about this also, so its radius, magnitude of R is also changing, right? And its angle, obviously its angle is changing because of this omega, and magnitude of R is changing because of this omega. Let me write, say this is omega dash, the oscillation along the rod. So, what we can say, what will be the acceleration in that case? So, I am telling you what will be the acceleration when both r and theta is changing. So, in that case, the acceleration of the particle in polar form means Say this is the particle, this angle is theta, as I said, this will be d theta, right? This is r, so r vector. So acceleration AC plus AT, and I can say AC is equal to R double dot. Acha, what is dot here means? Say R dot means dr by dt. Then which are d mod r by dt. So dot is implies basically d by dt. Okay, dot at the top of an alphabet here, physical quantity is just d by dt something. So R double dot minus r omega square. So I write r omega is what? Theta dot square into what? Er plus tangential r alpha. R alpha is what? Theta double dot plus 2 r dot theta dot, and then this could be et, you know. So that is, in this problem, along the, this is what? Centripetal means, I should say radial. So this is the radial acceleration, this acceleration is for the bead, it will be towards along the rod, and along the rod there is a no friction, so there is a no acceleration, there is a no art, this value is not come into the picture here, then if we see here this part, that is tangential acceleration, तो देखो इसमें एक part है 2r dot theta dot, what it is 2r dot, so this is 2r dot theta dot, and this is what? Tangential acceleration, in this problem I'm telling you that omega is given constant, so theta dot is constant, so theta double dot is what? 0. So there is no this acceleration, but there is acceleration 2r dot theta dot. What is this? This is 2r dot, which 2 dr by dt, means this is the velocity along the rod, into theta dot. Theta dot is omega. So basically there is a cross product. Basically it will be, in fact it is omega cross b. But this omega is what? This one. And this v is what? This one. Right? So this omega is theta dot, means the angular speed of the axis, about the axis, the motion of rod about the axis, omega. And v is the motion of the sling along the rod. So if you see the cross product omega cross v, omega is this, v is this, so this force is like this. So it is the perpendicular to the length of the rod, and it is in the same plane in which the rod is revolving, is the cross product. And then there is a one force also act, this is a bead, this is mg and this is n, but one force is also act in this direction, I can say dot, and this force is there, this acceleration is there, this is called Coriolis force or Coriolis acceleration. So this acceleration, due to there is acceleration, so there is a force, and who will provide that force? That is nothing but the rod, reaction of rod. So other reaction will be on in the plane of the rod. So one reaction is n and other is this. So together, these two reactions together, these are perpendicular. So net reaction is what? N square, and say this is n dash square, n dash square. This, and that will be greater than mg, because n is equal to mg. So we can say, this is how we can say that option D is also correct. So This is how we will say this thing, right? So because these are this is the contact force also act in the same plane, perpendicular to the rod, like that, right? Like this. So now, so this is also correct. This one. So I hope, student, you got this question, and would you like to solve the same question from simple harmonic motion? So yes, you can do. It's not difficult at all. What you do? If you want to find the maximum velocity with help of simple harmonic motion, yes, you can do it. It's not at all difficult. Take, with respect to non-inertial frame, take some position x, which is say just slightly greater than xe, right? After xe equilibrium position, take some position x. What happened? The restoring force is equal to what? Mass into acceleration. And from there also you can find the maximum velocity, because what is the maximum velocity that maximum velocity is a omega. So once we get omega means what? Omega is not the omega of this circular motion, omega for the simple harmonic motion. When what this is the omega, the angular frequency to which the bead is oscillating about along the rod with respect to non-inertial frame, with respect to the rod. So well, if you want to do this question by SHM, definitely we can do, and just so take this and consider, if I'm telling very basic, that some position is say this is x dash, right? This L naught plus x dash I'm saying, and x dash I'm saying x e plus x. Say this is x e equilibrium. This is x. So what is the force acting on it? The force acting on it here is m omega square L plus x dash, and this side is what? K x dash. So what is the net force? F net is m omega square L plus x dash minus k x dash, right? So what we can write? We can write, let me write m omega square L x dash. I can, let me write x e plus x, and here also let me write k x e plus x. Otherwise also we can do only to see restoring force, but let me do with the very basic so that you will able to understand. मैंने क्या किया कि किसी मोमेंट पे एक्स डैश इलोंगेशन है, और एक्स डैश मैंने क्या मान लिया? एक्सिस से थोड़ा ज्यादा है, ठीक है? एक्स सी प्लस एक्स को मैंने एक्स डैश मान लिया, ठीक है? उस समय उस बीट पे क्या फोर्स लग रही होगी? एक तो सेंट्रीफ्यूगल फोर्स, मैं किसके रिस्पेक्ट में देख रहा हूँ? नॉन इनर्शियल फ्रेम ऑफ रेफरेंस के रिस्पेक्ट में देख रहा हूँ। एम ओमेगा स्क्वायर एल प्लस एक्स डैश माइनस के एक्स डैश। तो मैंने एक्स डैश को एक्स ई प्लस एक्स लिख दिया, और ये हो गया एम ओमेगा स्क्वायर एल प्लस एम ओमेगा स्क्वायर एक्स ई प्लस एम ओमेगा स्क्वायर एक्स माइनस के एक्स सी एंड माइनस के एक्स। और आप जानते हैं स्टूडेंट्स कि एम ओमेगा स्क्वायर के एक्स ई इसके बराबर है, राइट? के एक्स सी आपने देखा इक्विलिब्रियम में, आपने इक्विलिब्रियम में क्या देखा? यहाँ पे के एक्स ई kx is equal to what? M omega square L plus x equilibrium. तो आपने kxe is equal to m omega square L plus xe, means this plus this is equal to this, means this plus this is equal to this. तो ये क्या हो जाएगा? कट हो जाएगा। तो क्या बचेगा? ये मिला दे, कट हो गया। क्या बचा आपका? m ओमेगा स्क्वायर x माइनस के एक्स। And I can write x common. I can write m omega square minus k. And let me write it will be minus of k minus m omega square x. Right. So this is a net force, and net force is equal to what? Mass into acceleration is equal to minus k m omega square x, and we know that the motion is SHM because A is proportional to x. So minus x. So the motion is SHM, and then we know I'm saying this frequency to be omega naught square. A is equal to omega square x. So let me say because omega is given for the motion, for the circular motion of the rod about the vertical axis. So let me write this to be omega naught square. So I can say from SHM, omega naught square, that is the motion of the bead along the rod, the synchronic motion is what? This will be k minus m omega square by m. So this is rho. Then what is the maximum velocity? You know very well, maximum velocity is a omega. And you know what is A? That is from the initial position to mean position is A, amplitude. And that already you got it. That is what? Xe into omega. That will be k minus m omega squared by m. And value of Xe you got. Value of Xe, you got it. M omega square L upon k minus m omega square. So you put this value there. That will be m omega square L upon k minus m omega square. And this is k minus m omega square upon m. So this m and this m, it will be root m omega to the power 4 L square I can say, and this k minus m omega square. So I got this is even bit simpler. You have to do less. You do not have to apply the integration and all. 100 के बिना आप इसको SHM से कर सकते हैं. और जब मैक्सिमम इलॉन्गेशन की बात हो तो डायरेक्ट कर दीजिए 2 times of x equilibrium because the motion start from rest. So simple now. So you can do this question from SHM, from work energy theorem. I hope you got this question clearly. Still, if you have any doubt, you can discuss to me. Thank you for watching.